The front maiden, which goes on and off, so that way you can take the flyer and the bobbin on and off, the front maiden was so badly worn that it was just flopping all over the place. So I ended up having to put a piece of nice square piece of wood in there, and then I cut away the worn part of the maiden itself so that the maiden and the mother of all mesh perfectly now, a nice and tight fit. Here, the bottom of the mother of all, these threads here were shot, they were stripped, and this was the nut that was on them. So what I had to do was I bought a old-fashioned wood clamp, which uses wood threads and wood nuts. So I stole parts from there, I cut them out of the wood clamp, and if I can tilt this up here, I put an entirely new set of wood threads over the old threads with the new wood nut. And I even had to space it down with a wooden washer and a wooden spacer here to give a nicer, better grip, fuller grip. So you don't have to really crank on that at all to get it tight. It tightens down beautifully with very little pressure. So the nut that was down there actually moved up here because this nut was missing. Crazy. So that worked out good. I actually cut it down a little bit and smoothed it out, made it look nice. The maidens used to support the flyer simply by means of wood support here and a hole in this maiden back here. I decided against that because that was causing so much friction that you really had to pump hard on the spinning wheel to get the flyer to turn smoothly. See how nicely that spins? It just spins with very little pressure. It used to not spin well at all because of the friction between the wood and the flyer metal axle. So I ended up putting in a metal piece here, which is bored out so that it's metal on metal here, and I put a washer back here that's the exact same diameter as the axle of the flyer. Also, when I was talking about this brake, this is a really nice brake that I designed and built right here. It's got a nice handle on it. What's really neat is all the brakes, all of the bobbin brakes that I'd seen on the internet and on all the videos of people spinning, is they didn't have a perpendicular handle like what I built here. See that perpendicular handle? All they had was a knob sticking out right here, and that's actually what I started with. The problem with the knob is because it is symmetric in every way, it's circular, you can't tell, where you are at as you spin that knob. So if you spin the knob a little bit and then the brake isn't right, so then you want to spin it again, you can't tell, where you were at and where you're starting from and where you're ending. So I put this nice handle on here, so now it's really, really simple to tell where you're at, and not to mention it's a lot easier to turn that brake. And here's how a bobbin brake system works. It's a simple line, spring loaded on each end of the line as it goes up and over the pulley on the bobbin. So you have your free-floating bobbin there, and that brake line goes from a hook here, up and around, comes back down and through that hook, and over and curls around this little handle here. And the handle is simply held in place by pressure on a screw through this piece of wood. So even the slightest turn of this handle adds or releases pressure of that loop that goes up and around the bobbin pulley. By varying the pressure that you're applying via the brake line onto the bobbin, you will be regulating the amount of fibers that are drawn onto the bobbin, because as the flyer is trying to wind fibers around the bobbin, by adjusting the brake line, you're varying the speed of the bobbin, either faster or slower, as to how quickly the flyer pulls the fibers onto the bobbin. So besides the speed at which you're treadling the spinning wheel, this is a nice way to vary the amount of how quickly the fibers are drawn in, so that you have some control over how the the rate of twist is put onto the fibers. when I started with the brake handle over here, because that's where I'd seen everybody on the internet has the brake, is on the right side of this assembly. But most people are right-handed, and I did not feel comfortable feeding the fibers in with my left hand as I'm trying to adjust to the brake with my right hand. So I felt much more comfortable having the fibers in my right hand because, you know, I'm spinning at the same time I'm trying to adjust the brake. So I moved the brake to the opposite side, which meant just moving stuff around here. That worked out slick. That worked out beautifully. Now on a single belted spinning wheel, you can see how as I turn the main wheel, the flyer turns with the main wheel, but the bobbin stays still. That's because on a single belted spinning wheel, the bobbin only turns, I'll pull the leader off here a bit, the bobbin only turns when it's being tugged around by the fibers that you're spinning. You can see how the bobbin is turning now as I crank the flyer around. See how it turns? And there's a brake line here that actually can be adjusted now to slow the bobbin down to different speeds. So the bobbin on a single belted spinning wheel always spins equal to or less than the speed of the flyer. So on a single belted spinning wheel, to give yourself a ratio of how quickly the bobbin spins in relation to the main wheel, all you can really do is count how many times the flyer comes around. So your ratio is going to be equal to that rotation or less for every spin of the main wheel. Another thing I had to do is, we have a tile floor upstairs, and when I was first starting to test the spinning wheel to see if it worked, the spinning wheel was sliding all over the place because it was just wood on tile. So what I did was I bought some gum rubber feet for the spinning wheel. They're not just a hard plastic foot. They're gum rubber, so the gum really sticks to any like wood or tile surface that you might have the spinning wheel on. So that was a good improvement.